lot of graphing. Part of that is all going to be based off a few functions that we will see over and over again. So that's what we're going to look at today, those common ones that show up a lot. My goal today is just to get through this graphing piece, and then next week we'll pick up with the rest of it. Okay, so I figured if I went too far today, nobody would remember it next week anyway. So, first thing, we do have a definition. If I talk about continuous, when something is continuous, it's basically if you can draw it without picking up your pencil. Okay, so if I draw a graph like this, I can draw that whole thing without picking up my pencil, no problem. But if I have a graph like this, I have to pick up my pencil. Oh, the air's finally kicking on. So this one is not continuous, that one is. We can use intervals to tell where a graph is continuous. When you do this, always use the x value. Okay, you don't want to tell me ordered pairs, you don't want to tell me a y. You give me an interval with an x. The reason being, if it's a function, and I say when x is 1, x is only 1 at one place on your graph. But if I said y is 1, is it possible that your graph was equal to 1, that the y value was 1 multiple times? In some situations, yes. So x never gets repeated in a function. That's why we use that to describe those intervals, because the x would only happen one time. So let's look at these graphs, and we're going to tell where they're continuous. The first one, I do apologize, it's kind of hard to tell there. There is an open circle right here. The tick mark for the 2 kind of filled that in. So that is an open circle. So is this graph continuous everywhere? I would have to pick up my pencil to jump over that open circle piece, right? But it's continuous everywhere else. So if I want to describe where it's continuous, I'm giving my x, it's coming from negative infinity, it stops right here. What's the x value right here? 0. It's not continuous there, so that gets a parenthesis, union, parenthesis, everywhere after 0, 0 to infinity. So this graph is continuous everywhere except 0 itself. If I look at B, is this graph continuous? Yeah, I can draw that whole thing without picking up my pencil, so it's continuous from negative infinity to positive infinity. Hi, where is this one continuous? Or maybe I should say, where is it not continuous? At 2. So everywhere else. Negative infinity to 2, union, 2 to infinity. D, where is that one continuous? Everywhere. Negative infinity to positive infinity. Okay, so always give me the x values. Okay, second thing that we need to talk about is increasing, decreasing constant. So this is just telling us if our graph is rising or falling. Increasing is just anything that is rising as you go from left to right. Decreasing is anything that's falling. Constant is no change. With those, just like when we're talking about continuity, you always have to give the x values. Because if it's a function, the x is unique. There is only one place where x is equal to that. One thing to be careful of, it never fails. I'll put something like this on a graph, and people tell me it's decreasing because that line, the arrow is going down. You have to go left to right. As I go from left to right, my graph is rising. So don't look at the arrows, the direction the arrow is pointing. Just as I go left to right, what is my graph doing? So now we're going to graph our common functions. This one, the identity function. F of x is the same thing as y. If I say y equals x, you could have graphed that on your test yesterday. Y equals x. That's a line with a y-intercept of 0, slope of 1. So up 1, over 1. What's the domain of that? Okay, positive infinity. What's the range? On these, I'm not ever going to expect you to just memorize domains and ranges or anything like that, but if I tell you that you have the identity, you should be able to draw a graph, and then you should be able to look at the graph to answer any questions. Is this one continuous? Yep, whole thing. Is it increasing, decreasing, or constant? Increasing. Negative infinity, constant. Let's look at our square function. If you don't know what something looks like, how do we figure it out? Can we plug in points? We don't just want to use our graphing calculators since we wouldn't have those on a test, so we need to try to make sure we can get our graphs without them. But we can always make a t-chart. We'll have a basic calculator at least. You can plug in numbers and evaluate things without a problem. So if I plugged in 0, 0 squared, 0. I put in 1, 1 squared is 1. I plug in a 2, 2 squared. If I did 3, 3 squared, is this enough? What do I need to put in? Let's do the other side, some negatives. If I do negative 1, what's negative 1 squared? 1. What's negative 2 squared? Positive 4. Negative 3 squared, positive 9. This is one you saw a lot last year, talking about our parabola. So x squared gives us this parabola. What is the domain there? Domain is your x going left to right, negative infinity, positive infinity. Range is your y, so going from the bottom up. Where does this one start? 0. Would it get a parenthesis or a bracket? Bracket, because I do hit the 0 and then it goes up forever. If I asked you increasing, decreasing, constant, what does this graph start off doing? Decrease. So from negative infinity to 0. Technically, it doesn't matter if the 0 gets a parenthesis or a bracket. Since it's a closed point, you could do either. I think when we do Math Excel, it always asks for parentheses, so, but it won't matter. Increasing. After 0, as I go on, this goes up forever, so it's increasing from 0 to infinity. Is that one okay? Alright, I want you guys to take a second, plug in points, and see if you can figure out what this graph would look like. And negative. 0 to the third is 0. 1 to the third is 1. 2 to the third. Negative 1 to the third. Negative 2 to the third. This one is giving us our chair. What's the domain? Range? Increasing, decreasing, constant. Increasing the entire time. Kind of flattens out a little bit in the middle, but it never stops rising. All right. Any questions there? All right, so what if I said the square root function? If I put in 0, the square root of 0 is 0. Square root of 1. Can I do 2? Not nice. What would be another nice one we could do? Square root of 4 is 2. What's one more nice one? 9 gives me. Okay, this one. Can I do negatives? No. If I put a negative under my square root, I get an I. So it starts at 0, 0. It is only continuing on to the right. It does not extend to the left. My domain then would be, okay, and we hit the 0 so it gets a bracket. My range, my y's, increasing, decreasing, or constant? Increasing. More slides. Cube root. So if I make a T-chart, cube root of 0, cube root of 1. Okay, can I do 2? What would be a nice one? 8. The cube root of 8 would be 2. Can you do the cube root of negative numbers? Yes, you can't do the square root, but we can do the cube root. Because when we cube negatives, you still get a negative. So the cube root of negative 1 is negative 1. Cube root of negative 8 is negative 2. So the cube root is like our cube function flipped on its side. It's a sideways chair. Domain. Range. Increasing, decreasing, constant. Increasing the whole time. I want you guys to try the next one. Make your T-chart, graph that one. Hello. Okay, thank you. Caitlin, you're leaving. So we're going to do the last two slides here, and then there's a handout with some questions. It shouldn't take very long, especially if you have your notes handout. Most of the information's on your notes. So what does absolute value do? Makes everything positive. If you put in a positive number, it doesn't change it. If you put in a negative, it becomes positive. So you have 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. What's your graph turn out to be? Yeah, it's got a corner, so it's probably a little more of a V. Something like that. Nice fact that my slate has a delay in it today, and that really messes up my graphs. So my domain, what would that be? Range, what y's do we hit? 0 to infinity. Increasing, decreasing, constant. What does it do after 0 though? Alright. Any questions there? So, last slide I want to look at today. If I asked you to graph x equals y squared, would it be easier to plug in values for x or for y? All of the others we were plugging in things for x because they were y equals. Y equals. If you had an x, you could easily find your y. What would I plug in for on this one? The y. And then to get my x, I can do y squared. So if my y is 0, 0 squared is 0. If y is 1, 1 squared is 1. Y is 2, 2 squared is 4. If I put in negative 1, what do we get out? 1. If I put in negative 2, 4. So if I plot these, what do we get? Have a parabola flipped on its side. Is this a function? No, why not? We don't have to do increasing, decreasing, constant here. That really only applies to functions. If it's like this, I can't really say if it's rising as I go left to right because it's doing both. So we would not do increasing, decreasing, constant. Any questions? There's a handout posted on Classroom. probably still have free time. So everybody get that out and get that done, please. Oh, yeah, yeah, you can have a seat now. I'm done with my notes. So. Sorry, that just hit me about 30 seconds ago. What? Oh. Oh, okay, no problem. Thank you. We had a no cleanup day. I